Welcome students, this is your AP Statistics tutor, David Cho. Throughout this video, we'll learn deeply about the two-way frequency table. Based on what we learned on the first video, one-way variable data is a method of visualization of data with one variable. It consists of a single variable and frequency of each variable. For example, from this data table, we can infer that 8 students has their favorite color as brown, 15 students have their favorite color as yellow, and so on. The two-way frequency table, on the other hand, consists of two variables. Let's take a look at this table. It has variable 1, which is like university, and variable 2, which is an income level. In this case, the number in the table represents a frequency of the data that satisfies both conditions. For instance, the number 35 here represents the number of students from University A whose income is under $20,000. Likewise, the number 40 right next to 35 represents the number of students from University B whose income is under $20,000. And here are some questions for you to try on your own. Please pause the video and solve 4 questions below. Okay, so the answer for question A, how many students are from University A, should be the sum of the number of students with all income levels from University A. Thus, the solution should be 35 plus 90 plus 35, which is 160. With the similar method, the answer for question B, how many students are from University B, should be 40 plus 63 plus 37, which is 140. To answer question C, how many students have income level between 20,000 and 39,999? We should consider students from both universities who satisfy the given income level. Therefore, we have to add 90 and 63, and the answer should be 153. And lastly, the answer for the last question, how many students were in the survey, should be the sum of all students or all the numbers on the table. So if we add all of them, which is 35 plus 40 plus 90 plus 63 plus 35 plus 37 is equal to 300. Okay. Now let's move on to the types of frequency from the two-way frequency table. Often we need a frequency or proportion of the limited number of population. For example, if we want to know the population of boys who can jump higher than 1 meter, we cannot include girls in the population during calculating the proportion. This can cause the difference in types of frequency. Let's take a look at the first one, marginal relative frequency. This is a frequency where we divide partial sum by the total sum. For instance, 82 divided by 219 represents the proportion of subjects whose age is between 18 and 22. Second, joint relative frequency is one that divides a specific number that satisfies both conditions by total sum. For instance, 78 divided by 219 represents the proportion of subjects who use Facebook and at the same time have an age between 18 and 22. Lastly, conditional relative frequency is one that divides a specific number that that satisfies both conditions by partial sum. For instance, 78 divided by 82 represents the proportion of subjects of age between 18 to 22 who use Facebook. Mm, Again, here are some questions for you to try. So please pause the video and determine the type of frequency and calculate the proportion of each question. Okay, so the first one, what proportion of people use Facebook and has age from 18 to 22? So let's figure this out. First of all, we have to identify the population of this entire sentence. Proportion of people use Facebook and has age from 18 to 22. Since the population of this question is people, or the total number of sample in this study, so it should be, what is it? 219. And it says, and the sample should be people who use Facebook and has age from 18 to 22. So it should be someone who uses Facebook and has age of 18 to 22. We have 78 of those people in total. So since it's this specific number divided by the entire sum, the type of frequency should be joint relative frequency for A. B, what proportion of people who doesn't use Facebook has age more than 23? So the population of this entire sentence should be people who doesn't, actually people who don't use Facebook. People who don't use Facebook, we have 71 people, and the sample or the numerator should be people with age more than 23 in that population, which is 67. Since this is a specific number divided by the partial sum, the type of frequency should be conditional relative frequency. And lastly, the proportion of people who use Facebook, which is proportion. So the population should be the entire people because it says proportion of people, and we have to find those people who use Facebook, which is here. So this one should be marginal relative frequency. Since we're dividing partial sum, since the numerator of the fraction is partial sum and the denominator of the fraction is entire sum. Now let's calculate the proportion. So the first one, what proportion of people use Facebook and has age from 18 to 22? Since it is joint relative frequency, we have to divide a specific number by the total sum. In this case, we have to divide 78 by 219, which is about 35.62%. Second, what proportion of people who doesn't use Facebook has age more than 23? Since it is conditional relative frequency, we have to divide the specific number by the partial sum. So let's first look at the population. The proportion of people who doesn't use Facebook doesn't use Facebook. We have 71 of those people and has age more than 23. We have 67. So the numerator should be 67 and the denominator should be 71. If we divide 67 by 71, it is around 94.37%. Lastly, what proportion of people use Facebook? Since it was marginal relative frequency, we have to divide the number of people who use Facebook by the entire number of people in the sample. So in this case, we have to divide 148, which is the total number of people who use Facebook, by 219, which is total number of people in this like sample, which is around 67.58%. Okay, let's try out some Khan Academy problems. Two-way. Let's try these two practices. Oh, actually, the question says researchers once surveyed college students on their Facebook use. Oh, it was the same graph that I used for the example. Okay. Approximately what percent of students in the 18 to 22 age group use Facebook? So the population in this question should be students in the 18 to 22 age group, and the sample or the numerator part should be those who use Facebook in this age group, which is 78 and 82. So if we divide 78 by 82, 78 divided by 82, it's around 0.9512. Since it's percent, it's 95%. Tate works at an ice cream stand. Every customer can choose one of two toppings, sprinkles or chocolate chips. He recorded the age group and the chosen topping for a sample of 120 customers. Here are the results. Of the adults in the sample, what fraction ordered sprinkles? So the population of the sentence should be adults in the sample. So here we have 48 adults in total. And what fraction ordered sprinkles, which is 13. So the answer should be 13 divided by 48. Hey. Next one, researchers ones. Oh, okay, this is the same data table. And approximately what percent of students in the sample do not use Facebook? Let's do a quick review here. So we're trying to get the proportion of what students in the sample who do not use Facebook. So it's this one divided by the entire sum. And the type of two-way variable frequency was marginal relative frequency in this case. So if we divide 71 by 219, 71 divided by 219, which is around 32%. 32. Okay. Let's try another, like one more practice and then wrap this up. So, a survey asked participants whether or not they were vegetarian and how important they thought saving energy was. The two-way table of raw relative frequencies below shows the data. Oh, so in this case, instead of the frequency or the number, they gave us the proportion of the like samples. Based on the data, which of the following statement must be true? Okay, let's check the first one. 33% of people surveyed were vegetarian and thought saving energy was not important. So people surveyed were vegetarian. So the A could be correct if the sentence was 33% of vegetarian thought saving energy was not important. Because this one is the proportion of only vegetarian, not the entire population. So the A is incorrect. B, if a person thought saving energy was very important, here, they are more likely to be a vegetarian. Mm, this one sounds to be true because we have a more proportion of people vegetarian who think saving energy was very important. However, if the entire number of non-vegetarian people were higher than vegetarian people, let's say we have 10 times more people 10 times more non-vegetarian people than vegetarian people, then we're gonna have more non-vegetarian people who think saving energy is more like very important. So B is wrong. Actually, B is not sure. C, a person who was not a vegetarian was more likely to think saving energy was very important than not important. Person who was not a vegetarian was more likely to think saving energy was very important than not important. No, this is incorrect since we have lower proportion for very important than not important. Lastly, a person who was not a vegetarian. Oh, wait, actually. Oh, yeah. A person who was not a vegetarian was more likely than a vegetarian to think saving energy is somewhat important. Yeah, this is true because if we randomly pick one non-vegetarian people, there's 36% of that person being a person who thinks saving energy is somewhat important, while that of vegetarian group was 17%. Alvaro is interested in the relationship between weather condition and whether the downtown that run a train runs on time. For a year, he records whether each day is sunny, cloudy, rainy, or snowy, as well as whether this train arrives on time or is delayed. Here are his results. Which of the following statement is true? When the weather was rainy, it was more likely for the train to be delayed than on time. So let's consider the date where it was rainy. It says more likely for the train to be delayed than on time. No, this is wrong because among those 55 rainy days, we had 40 days where the train was on time and only 15 days that where train were delayed. So A is incorrect. B, when the weather was snowy, it was more likely for the train to be delayed on time. Snowy days. Yeah, it is correct because among 20 snowy days, we had more delayed days than more on time days. So the answer should be B. A survey of a random sample of ninth grade students from Alabama asked whether the students owned a cell phone and whether they had brought a personal electronic device to use for schoolwork that day. The two-way table of raw relative frequencies below shows the data. Based on the data, which of the following statement must be true about the ninth grade students from Alabama? Okay, so A, 57% of the students in the sample do not own a cell phone and did not bring a personal device. This is incorrect since this 57% is only for this entire population. B, a student who owns a sample is less likely to have brought a personal device than a student who does not own a cell phone is. A student who owns a cell phone here is less likely to have brought a personal device than a student who does. No, this is incorrect since we have 80% of students who own cell phone brought device, whereas we only have 43% of students who does not own cell phone brought device. So this is wrong. C, a student who owns a cell phone is more likely to have brought a personal device. Yeah, this is correct since it's entire opposite of B. A school in New Zealand collected data about the employment status of the mother and father in two-parent families. The two-way table of column relative frequencies below shows the data. Based on the data, which of the following statements must be true for the two-parent families at the school? A family where the father works part-time is twice as likely as a family where the father is not working to have the mother work part-time. Father works part-time is twice as likely as a family where a father is not working to have mother work part-time. Oh yeah, this is correct. Since we have 14% of the first part of the sentence, whereas we have only 7% of the second part of the sentence, which is exactly twice. Okay, we're done for today's lecture then. I hope this video helped you for better understanding for AP Statistics. And if you have any questions, please visit Peer Tutoring Club or the study hall session. Or you can also visit peertutoringclub.com to look for more information. This is your tutor David Cho, and thank you for watching the video.